flew right through it. You had AB congruent to AD. Please, 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 make sure you're marking your diagrams. And there's your first step. That doesn't have a definition, it doesn't have anything else to say except just that. Go to the second one. BC and DC. Again, mark it. What's left? The reflexive, very good. The reflexive side is left over. So we have to mark up the AC. Is it wrong if you wrote CA congruent to CA? No. One of the things that happens a lot of times with these is that if I write it out as AC and you wrote it out as CA, as long as your letterings match out, it's okay. Sometimes angles, if you write, if I said ABC and you wrote CBA, but you made it go CDA and you've made the match up, it's okay. As long as your correspondence is fine, you're not wrong. Okay? As long as your correspondence isn't right. Excuse me. Do we have triangles now that are congruent? How? Yep. And now comes the part of the new thing for today. What happens when you get two triangles congruent? What happens once you get two sets of triangles that are congruent? Once you say that you have two triangles that are congruent, by any method, whether it's angle, side, angle, angle, side, angle here, if I say this is triangle A, B, C, and this one is triangle X, Y, Z. These two triangles are congruent by what are these two triangles congruent by? What follow tick marks? What is it? Angle, side, angle. Very good. So I can say these are congruent by angle, side, angle.
Why'd you write?
I don't know. This is funny. So have I mentioned it's been a weird day?
No.
So what happens here, if you look at the triangles, you really only have three parts of the triangles that are being said that they're congruent to each other. That leaves three other sets. Now, if these two triangles are congruent, what does angle C have to be congruent to? Z. It has to be. Okay? The reason that it has to be is because they correspond to one another. So what happens is, as soon as you can say that you have triangles that are congruent, all of the corresponding parts are congruent. So we use this thing called cpctc because it stands for corresponding parts of congruent triangles are congruent, because nobody wants to write that out. Pain. It's for when you have two triangles congruent, then all corresponding parts are congruent. So what we'll be able to do in a proof is use this as a reason. We'll be able to use that as a reason. cpctc. So if I come back to this, once I had triangles that were congruent, I could have said that angle C is congruent to angle Z because cpctc. That's all it means. That's that next natural step within writing proofs. And that's what this worksheet was actually trying to get you to start with originally. But yesterday, I thought it was too much to throw that at you, as well as going on your own. So what we're going to do today is make sure we got those proofs right, which I'm assuming by now, I mean, we're getting better at these, aren't we? They're not as scary and bad as they once thought to be. What I want you guys to see is, by looking at something like this and going back to where we were at yesterday, you had to prove that those triangles were congruent. You did. It was one of the easiest proofs that we can do. All you had to come up with is your reflexive side. You got side, side, side. Now, since you've got triangles congruent, if you look back to you kind of can go back and erase, because you crossed it out, you can then say that angle B is congruent to angle D because they correspond in here. So the reason is just C, D, C, T, C. That's the next step within proof. After you have triangles congruent, you can say that any other parts are congruent as long as they correspond to one another. That's how these work. Okay? More often than not, that would be your last step. There is one wrinkle though, and I'll show you that here in a second, the worst case scenario, if you will. So basically what this thing does, it gives you one extra step that you can say in the proof. That's it. That's all it is. And you can only use it, only, after you've said you have congruent triangles. Only after. You cannot do it before. Okay? And that's all. It's very, very easy to work with. Okay? So let's look at the second one. The second one is the goofy one on there because you have parallel lines. Hopefully you guys took to heart the idea of using the, what did I use? The diagonals to help you figure out your angle pairs. Because honestly, I've always thought that parallel ones are usually a bit goofier because you have to spend the time trying to figure out where your angles are going to work out. When it's an enclosed figure like this, and you have two sets of parallel sides, you're going to wind up alternate interior twice. If it's only one set of parallel, you only have them once. So start with the idea that you have these two parallel, and then just follow the diagonal. If you do that, it means that happens. So I'm getting ahead of myself a little bit, but that's how it's the easiest way to start these things out, by looking at the diagram to figure out which angles are you going to write. So BA, parallel to CD. That means VAC, bless you. It's congruent to DCA. And you have to put the ugly symbol in. Okay? You have to have that ugly symbol. Two parallel lines are cut by a transversal, blah, 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 blah. Then you do the exact same thing with the other set, okay? Exact same thing with the other ones. Oops. Parallel here and here. Bless you. Which means I go down, up through there, and back. Again, I have alternate interior on the other sides. Which means angle VCA, DAC. Same reason. I always think these are the goofiest ones because there's so many letters that are involved, okay? You've got two angles, you've got to find the side. Is it between it or after it? Between it, because it's reflex. Okay. You've got two triangles now that are congruent because you have two angles in the side between, so it's otherwise known as ABC and CDA. Which means y is angle B congruent to angle D. OG, what? Yeah. That's how it works. It's that next step. After you've shown that you have triangles congruent, what else can you say? Well, I can say corresponding parts. Yes, ma'am. Oh, was it? I'm sorry. I thought it was. So it wasn't the angles. It was the two segments. I forgot which one I was doing. There's another one that has C and D in it. What was it? What segments were they again? CD and BA. Hey, guess what? It's the same reason. Okay? So once you're able to go through and get the triangle, that's just the next step. One more line. That's it. That's all this is. Okay? Excuse me. What do you want? When you're going through here, you've got parallel here and here. So you have two parallel lines cut by a transversal, alternating here. And then it works the same way, going the other direction. Just redraw your lines out. I just kept it, instead of overdrawing my figure, I kept it within by showing you that little Z trick. Because then you know where that comes up. Here is one of the angles, and the other one where it goes down is the other angle. Another nice way to remember how to do it. Does that make sense? Let's skip ahead. Go to the last one on here. Hopefully you recognize the fifth one. Looks horribly suspiciously exactly like something we did in class yesterday. In your notes, I think the only one was different. I think we did the angle side out of that one instead, but it was the same one. With this diagram, they actually numbered all the angles.
Right.
You just use the numbers. Don't try to re-letter them. There's no reason. Whenever they give you numbers in diagrams, use them. It's just cleaner. It's a lot cleaner to use. So here it tells you angle 1 is congruent to angle 6. I mark it, 1 and 6. I do the same thing, 3 and 4. It's given. I mark it. So I've got two angles. I need a side either between them or after them. What do we have? Bless you. We have reflexive again. In between.
It's confusing because it looked like it was coming up. So
Because of what?
I was confused.
Do you have triangles? By what? Which means the segments are congruent. One suggestion I'm going to give you guys when it comes down to writing proofs and second guessing and all that, trust your instincts. You're probably right. Go with, if your first if your first intention is to do one specific step, do it. You probably are making a right guess. The more you try to second guess yourself, the more that you try and overthink it, rewrite it, and do something different, that's where you wind up the propensity to make more mistakes. But if you stick with your gut, stick with what you're thinking about to begin with, you're probably going to be fine. Okay? Don't overthink it. Now, the fourth one on here I think is the goofiest of them all. That's the worst case scenario one. Okay? The worst case scenario one is where they're asking you to prove a definition. But with all definitions, let's see this real quick. I might throw it away, but I might not. With all your definitions, they're on here, right? It was right side up on this side. I don't know. Why are you arguing with me?
I'm not arguing, I'm asking a question.
Whatever. Anyway, so what's nice is that
That's my grandmother, every time I try to talk to her, I get ready to ask it a question.
Grandma sounds cool.
No, she's not.
You and I agreed there. Did you see that? It's weird. Hell, I don't like it. What's nice about, even though it's the worst case scenario we have to prove a definition, your definitions and things are on here. Because angle bisector is on here. It tells you what does an angle bisector do. It creates two congruent angles. So if you work it backwards, if you show that you have two congruent angles, then you can say you've created an angle bisector. This is kind of the worst case scenario of working backwards. You have to do 2 steps instead of 1 when you're done. That's it. You're still using the definition, but you have to show it in a little bit different order.
Are you talking about four?
Yeah,
Are you supposed to say bisects? Don't do that.
I was just saying that.
Oh, yeah.
And then you got all angry about your grandma.
Lies.
My grandma flat out told me that she doesn't like me.
Same. But
She called Spencer
So enjoy your grandmas while you have them. Grandmas are awesome.
mine's already around.
So anyway, back to this. When you are working with all these, you still have to be able to prove you have a triangle. So you still do the same setup like you have been. Start with your givens and work your way through it. BC, convert to C. Mark the diagram. You go again. BCA and DCA. Mark it. For some reason yesterday, a lot of people were having problems marking those 2 angles. I'm not exactly sure why. So now you have a side and an angle, which means you have to find an angle before the side or a side after the angle. What do you have? You have another side. You have the reflexive side here. Are those 2 triangles now congruent?
Yeah.
They're both congruent because of side angle side. So in order to get that bar, you had to come up with 1 step. You had to come up with reflexive. Everything else was given to you real quick. Now you have to think about what does it mean to show that AC is a bisector. So if this was a bisector of angle BAD, you'd have to first find that bad angle. I know. Once you find that angle, you have to decide which 2 angles would have to be created to be congruent if AC was the bisector. Well, those 2 angles that would have to be created to be congruent would have been BAC and DAC. So what I do then is say that they're congruent. Because of corresponding parts of congruent triangles congruent. So thinking about what an angle bisector does. An angle bisector cuts an angle into two congruent angles. Well, if you say that backwards, if two congruent angles are formed by a segment cutting through them, then it was an angle bisector. So now we have shown that they've been bisected. So all you have to do is this. We've shown this because of the definition of an angle bisector. That's it. When you have to prove something that is a definition, the step before it, just show, all you have to do is show that it happened. So if I had to show that something was a midpoint, I'd have to say that two segments were congruent. If I had to show that something was a segment bisector, I'd have to show that two segments were congruent. If I had to show that something was an angle bisector, I'd have to show that two angles were congruent. That's it. This is the absolute worst case scenario that you can do. It does not get any goofier than that at all. Everything else is just corresponding parts and go. Okay? Does that somewhat make sense there? Because quite literally, it's still all on the progression sheet. You're just working backwards from that last step, and that's it. Everything else is the same. Okay? You're too strong for your own good. Yeah. Yes, ma'am. Like that little extra step? Oh, yeah. I don't know. I'm not the right answers. Great question, though, about test stuff. What I've decided, what I have is, I do already have a review sheet that I've made up. I already emailed it all out. It's already on the calendar if you want to get rambunctious and take a look at it. What I'm going to do tomorrow with the isosceles and equilateral triangle rules and things, those tend to become more algebraic than anything else. We could do proofs with them, but there's no reason because it's a very rare occurrence if we have a proof with those. So make sure that you guys have your calculators and stuff tomorrow. Isosceles and equilateral triangles, a lot of times what we do with those is we have to draw diagrams and fill in blanks with them. So we have to make sure that we are able to do that. There's a couple little rules with them, but they're really, really easy to work with. So tomorrow I will give out the hard copy of the review stuff, but if you want to be rambunctious, get ahead of the curve, look at some of the proof things that are on there, go for it. The test itself, the way that it's looking right now, it'll probably be some basic some algebra stuff, and then a couple of proofs. Whether it's 3 or 4 proofs is kind of where I'm keeping at it. You know, the fill in the blank style and on your own. The on your own proofs, generally speaking, I don't want to make them any more than 6 steps because you know if you given a couple givens, figure out something on your own and do triangles in a corresponding part. That's about all it is. I'm not trying to make them really difficult. Really, I'm not. As much as you don't believe that.
Yep.
So, excuse me, yes ma'am.
How are we supposed to know if we're supposed to use the cpctc on the proofs?
What happens a lot of times if you need to know that if you're going to use that, if you look at what you have to prove. In this first one, you're just showing triangles. Do you need that to show the triangles? No. In the second one, see how it says triangle, then a part?
Okay, so if it has a letter.
It has a part to it.
Okay.
Here I was saying just show the parts, which means you had to show triangles and then the part.
Okay.
When it says something about a definition, oops, got ahead of myself. When it says something about a definition, you'd have to show the part that creates the definition.
Okay.
And then you have triangle, and again, triangles and then the part.
Okay.
Does that make sense?
Yeah.
Good question. So what I have today, I've got a couple more proofs for us to start looking at. And I want to spend a little bit of time, give you guys a little bit of time and whatnot to work on them together, or in classes and go through. What's that? Yeah, I didn't want you guys to write all these out. And I apologize, I forgot to when I printed these things out, I completely forgot to resize them. Because most of these things I probably could put 2 on a page, but by the time I realized I should have done that, half of them were already printed. And I said, oh well. Yeah, but I haven't really used a lot of paper this year, so that kind of makes up for it. Absolutely. All right. We'll go from there. Well, when you're working with letters, just follow your techniques. So if you're saying, if you set oh, okay. Well, this one here, you're talking about the triangle with what's the word? Here's this is so that's why I was saying so we
Now I feel like my body is
Spacious.
just make sure the letters are going out. So, did everybody get enough of those going up? I didn't know if I had spares. Was this just yours? Yeah. Okay. Now, what I want to look at here, is that a couple things right off the bat. On the third one, there is a typo.
What's up with teachers and how those? I don't know. The third one? I'm gonna be the only teacher that doesn't get
Yeah, it'll never happen.
It's not gonna
On the third one, guys, it's supposed to say parallel. Yes, ma'am?
We need another one. I guess some of them different.
On the third one, it's supposed to say it's parallel. They're both supposed to be parallel. I just accidentally drew a congruence. That's all. Okay? The third one. The fifth one, go ahead and cross off. Like I said,
Fifth one, cross it off. Is this
the fifth
homework?
one, cross it off. Get it? Okay. The reason I'm crossing off the fifth one is because, like I said, decided not to worry about any proofs about isosceles or equilateral. It's not like it's a real difficult thing, but I think with the lack of, we don't have as much time as I'd like to be able to get into it, so it's not a big deal. So what I want you guys to do here real quick, because we got a little bit of time. Oops, I'm trying to put on here. I'd like you guys to take a couple of minutes and start on the first one. What you should be doing, besides not talking here for a second, what you should have in front of you for all of this, you have to make sure you've got your progression sheet. There's absolutely nothing in any of these proofs that you cannot find on a progression sheet. If you're still having problems figuring out where your information is on your progression sheet, or you can't read your handwriting, please, 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 grab a spare one out of the back, rewrite them, and go from there. Also, quick suggestion that I hope that everybody does right now. Take a picture of your progression sheet right now, because your test is in, what, a couple of days. Oh no! It's gone. What happened? It disappeared. But do you have a backup file?
Yeah.
Could you rewrite it?
Yeah. Well, that's a lot. Wait, we're allowed to do that? Yeah.
No, what's the whole point of me having you guys write these things out this whole
I
time?
don't know if you learn to get both of those.
Exactly. So, seriously though, guys, take 2 seconds, take a picture of your front and back, have a spare, because that way when you come to school on Friday and you realize that your angle side lost it, that way you can come in and grab a blank one right away and rewrite it before the test. Okay? Because if you don't have your progression sheet and you have it on your phone, I'm not letting you use your phone, but I'll let you come in, if you realize you lost it, gonna come in and rewrite it real quick, okay? So again, if you've lost yours, you can't read your handwriting, or you don't know where everything is on your sheet because you keep looking all over the place for it, grab a fresh one and rewrite it. It is a great way to study for this stuff. It really is. In the back by the picture. It's a great way to study for this stuff, okay? So go ahead, start on that first one. Go through your progressions. Follow the order. Mark your diagrams.
He should do. Okay, he should do that for the people that didn't do it and didn't do it.
It typically will be saying thin the hurt real quick. Okay? Some space here. Again, all you have to do is start with the given. Look at your progression sheet and fill in the blanks. You mark it. On your progression sheet, it tells you if you're given right angles, what do you know about them? They're congruent. So, oops, I forgot that wasn't given. So now those two angles are congruent. Because all right angles are congruent. Why? Because my sheet tells me so. I go to the next one. B's a midpoint. Mark it. What were the two segments? AB and BD. You have a side and an angle. Find another angle or find another side. What do you have to have? So, what reflects?
When will you have an angle?
It's very rare.
But if you were to have, like, in the packet, will there be one that you have to find an angle for it?
There are times, you could have, if you're looking at this triangle and, what was the other one, like this one, you get a little shared one in here, but it's very hard to do something like that with a reflexive angle. It doesn't happen very often.
So, like, finding an angle won't be on the tests that we have to find?
I don't think we ever had to use it like a reflexive angle. Like I said, it's very rare.
Okay.
Okay. Do you have two triangles that are congruent? How?
Side angle side.
Okay, so triangle ABC, DBC.
Why does it say prove angle A is congruent to angle?
Because you have, okay, that's why I asked. Because then that's how you know that you have to do the cpctc.
Oh.
First you gotta prove the triangles are there, that are congruent, and then you do that first.
Okay.
I had to learn.
That's all it
That
is.
makes sense now.
Can you check this one real fast?
That's how it works. Guys, all of your stuff just follows right through your sheets. You gotta pay attention to what you have written through, okay?
So when it says just like angle A and angle G or whatever, that's what you have to prove. First you have to prove that the triangles are congruent, and then you can prove that by this cpctc. It's kind of confusing.
Yeah, that's all it is.
Okay.
That's all it is. Okay, so like she was saying that if it says you have to prove an angle or you have to prove sides that are congruent, you have to show the triangles first. Then you can say that you have parts that are congruent. If it just says prove the triangles, prove the triangles. It's the idea of understanding what it's asking you to do. Okay? Like on this third one, you have to prove two parts. So you're going to use that cpctc twice. Okay? You can use that probably usually up to 3 times, because if you've got 3 parts, you can say up to 3 parts. Yeah, like I was saying, try to get through as much